Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 3.4 Factoring Polynomials Day 1. The first thing we're going to do is we're going to determine whether the given polynomial is a factor, or the given binomial, is a factor of the polynomial. If yes, we're going to write the factors. It will only be a factor of the polynomial if our remainder is 0 after we use synthetic division. Okay, so we're going to go ahead and use synthetic, which means I'm going to have -1, put that in the box. I'm going to have 1, -3, 1. I'm going to add, here we go. Bring that down, that's 1. Well, 1 times -1 would be -1. -3 plus -1 would be -4. -4 times -1 would be +4. 1 plus 4 would equal 5. So no, x plus 1 is not a factor of the polynomial. Let's look at number 2. Again, we need to go ahead and set up our synthetic. So we're going to have -2 in the box. It looks like, looking at our polynomial, that I need to add a 0 here because I have 4, 3, I'm missing the 2, so we have 3x to the 4th plus 6x to the 3rd plus 0x squared minus 5x minus 10. So I'll have 3, 6, 0, -5, -10. I'm going to add, drop our 3. So we have 3 times -2, which is -6. 6 plus -6 will get us 0. 0 times -2 would be 0. 0 plus 0 is also 0. 0 times -2 is again 0. -5 plus 0 would be -5. -5 times -2 would be +10, so our remainder would in fact be 0. So what we're going to do then to write the factors, because it is, we're going to go ahead and write yes, it is a factor of the polynomial. What I'm going to do is write this x plus 2 as one of my two factors. If you remember from when we were factoring in the past here, we ended up with certain number of sets of parentheses, which were and it ended up being our factored form. Okay, so we have x plus 2 is one of our factors. The other factor is the polynomial I'm going to write from here. So originally it was x to the 4th, so we're going to have 3x to the 3rd. Our x squared would be 0, our x would be 0, so 3x to the 3rd minus 5. That would be our final factored form. Okay? All right, on to factoring by grouping. Factoring by grouping is something I'm going to use when I have 4 terms, just like problems 3, 4, 5, and 6. What I'm going to do is I'm going to split my polynomial right down the middle. All right? When I split my polynomial right down the middle, I'm going to look at this first 2 terms as a group together and the second 2 terms as a group by themselves. All right? So in x to the 3rd minus x squared, what is my GCF? Well, my GCF in this case would be x squared. So what I'm going to do is write x squared. What is left from x to the 3rd? It would just simply be x. What is left from x squared? It would be -1. Okay? Then I'm going to do the same thing with my -9x plus 9. What I always want is for my x to be positive. So in order to pull out the GCF, I would take out a -9. I'm going to go ahead and put that right here by the other parenthesis. What's left from -9x? That again would just be x. What is left? What's positive 9 divided by -9? That would be -1. What you notice now is that the 2 sets of parentheses are identical. I'm going to think of those just like I would any variable I've ever had. Okay? So I can take this x squared and subtract the 9 from it. So I'm going to take x squared minus 9. That's going to be multiplied by x minus 1. So basically what I did is I wrote the two leading coefficients of our parentheses in a parenthesis together, and I wrote the two parentheses that are identical. I brought it down just one time. All right. Now, if you are looking at the x squared minus 9, what you may notice is that is the difference of two squares. And from the past, when we had the difference of two squares, I could take the square root of the first term. I'm going to have two sets of parentheses, Take the square root of the first term, put it at the beginning. Take the square root of the second term, put it at the end, positive, negative, and I have factored x squared minus 9. Now I do not want to forget about our x minus 1, and we are done factoring by grouping. Okay? So again, number 4, we're going to do the exact same process. I'm going to split this right down the middle. What is the GCF of my first two terms? It would be 3x. So I want to go ahead and rewrite these two with my GCF out of there. So it'd be 3x. What's 3x squared divided by, or 3x cubed divided by 3x? It would be x squared. What's negative 3x divided by positive 3x? It'd be negative 1. Okay? For the second group, what is my GCF between 15x squared and negative 15? That would be positive 15. So I'm going to write positive 15 in between. I'm going to have my parentheses. 15x squared divided by 15 is going to leave me with x squared. Negative 15 divided by 15 will leave me with negative 1. All right. Now, just like I did over here, I'm going to take this 3x and this positive 15, put them in a set of parentheses alone. I'm going to take my x squared minus 1 and my x squared minus 1, put them in a set of parentheses by themselves. Okay? Now what I'm looking for is anything that I can factor. So in this first set of parentheses, 3x plus 15, I do have a GCF. The GCF there would be 3. So I can pull out a 3. What's left from 3x divided by 3? It's just x. What's left from 15 divided by 3? It would be positive 5. Now looking at my x squared minus 1. Again, what you're looking for, because I have an x squared, is the difference of two squares. Well, x squared is a perfect square. I do have a subtraction sign, and 1 is a perfect square. So that could actually factor into two sets of parentheses. The square root of x squared would be x. The square root of 1 would be 1. Addition, subtraction, and I am done. Okay? On to number 5. On to number 5. I'm going to split this right down the middle. I'm going to look at these first two terms. What is the GCF between x to the third and x squared? Well, that would be x squared. What is the GCF between negative 4x and negative 4? Again, I want my x to be positive, so it would be negative 4, so I could make my x positive. All right. So now I'm going to write my first GCF out front, x squared. What is left from x cubed plus x squared? Well, if I take x cubed divided by x squared, I'd end up with x. If I take x squared divided by x squared, I'd end up with positive 1. Make sure I put the other GCF in between. Now, if I take negative 4x divided by negative 4, I end up with positive 1x. I'm sorry. Shouldn't have written that 1 there. Positive 1x. Negative 4 divided by negative 4 would end up with positive 1. Now I'm going to group the x squared and the negative 4. So I have x squared minus 4. I'm going to bring down the identical parentheses just one time. Again, with x squared minus 4, I have the difference of two squares. So it would be x and x because the square root of x squared is x. 2 and 2 because the square root of 4 is 2. I have an addition and a subtraction. I'm going to leave my x plus 1 in the back end, and I am done again. Okay? On to number 6. We're going to split it right down the middle. Split it right down the middle here, okay? What I'm going to look for is the GCF between 2x to the third and 2x squared. In that situation, it would be 2 and x squared. All right, so if I write that out front, 2x squared, make a set of parentheses. What is 2x to the third divided by 2x squared? That would leave me with just x. What is negative 2x squared divided by 2x squared? That would be negative 1. Now on to the negative 50x plus 50. The GCF here, I want to make my x positive, would be negative 50. So I can go ahead and write that in between. Make a set of parentheses. Negative 50 divided by negative 50, or negative 50x, I'm sorry, divided by negative 50 would be positive x. Positive 50 divided by negative 50 would be negative 1. Just like I have done every other time now, this 2x squared, this negative 50, will be put into a set of parentheses alone. The identical parentheses will be brought down one time. Now I'm looking to try to factor this 2x squared minus 50. You may think right away, well, there's an x squared, there's a negative sign, difference of two squares. That's not a bad thought. The problem is 2 is not a perfect square and 50 is not a perfect square. So where we're going to go here is GCF. 2 is divisible by 2. 50 is divisible by 2. So I can take out a GCF of 2. That leaves me with x squared minus 25. I still need to have my x minus 1. Now, x squared minus 25. Again, we want to think difference of two squares. So I have 2 sets of parentheses. Is x squared a perfect square? Yes, it is. Square root would be x. Is 25 a perfect square? Yes, it is. Square root would be 5. Addition, subtraction. And don't forget about your x minus 1. All right. That is factoring by grouping. I understand that can be a little challenging to start with, so make sure if you're really struggling with that you either come in before school tomorrow or you come in with some questions during class. All right? All right, on to the back. We have the sum of two cubes and the difference of two cubes. What you see there is I have a cubed plus b cubed. If you look down here, it's usually going to look like something like x to the third and 125. Those are both perfect cubes. Okay? It's not going to be a cube, b cube like this. But what those two spots up top there are showing us, this area up here is showing us, is the formula that we can use so that we can factor them right away. All right? So I have a cube plus b cube. What you notice, whether we're looking at the sum of two cubes or the difference of two cubes, is the first set of parentheses is going to have the same sign as whatever our problem had. Okay? The second set of parentheses is going to have the opposite sign first, and then the last sign is always positive. So how you can think of your formula is same sign, opposite sign, always positive. All right? The first set of parentheses will be the cube root of a, and the cube root of b will fill in the first set of parentheses. The second set of parentheses, we'd have a squared, we'd have a times b, and we'd have b squared to fill in our three blanks. Now that might be a little confusing. Let's just try to work through a problem and see how it works. Remember that when I go to fill in my parentheses, it's same sign, opposite sign, always positive. So let's look at number 7. X to the third, is that a perfect cube? Yes, it is. 125, is that a perfect cube? Yes, it is. If I take the cube root of x to the third, I will get x. If I take the cube root of 125, I will get 5. Okay? So now what I'm going to do is have two sets of parentheses. One smaller set and one much larger set. Remember, for my signs, I'm going to have the same sign, the opposite sign, and then always positive. I'm actually going to move this parenthesis over here. So, for the sum of two cubes, it's same sign, opposite sign, always positive. All right? So now what I do is I'm going to take, for the first blank, it is a, the cube root of a. Well, a is my first term. So x is the cube root of x to the third. Then it'll be the cube root of b. My b is my second term. So 5 is the cube root of 125. For my first blank in my second set of parentheses, it will be a squared. Well, a is x. So I have x squared. The second blank is a times b. Well, a again was x, b was 5. So it would be 5x. Guys, you don't have to draw all these arrows or all these circles. I'm just trying to draw your attention to what I'm talking about, okay? The last blank here is going to be b squared. So 5 squared would be 25. All right. On the next one, what I will do is I'll actually write it out a little bit different, so you can hopefully remember the formula a little better. All right. So on to number 8. What is the cube root of x to the third? It would be x. What is the cube root of 27? Well, it's going to be 3. So my a would equal x. My b would equal 3. Remember, I'm going to make up two sets of parentheses. I'm going to make up two sets of parentheses. The first parentheses sign is going to be the same as the sign in here, so negative. The first sign in my second set of parentheses will be opposite, so it's going to be positive. My last sign is always positive. Okay? The first blank is going to be a squared. Well, my a is x, so it'll be, or I'm sorry, it will not be a squared. It's just going to be a. My second blank in my first set of parentheses is going to be b, so that would be 3. My first blank here is a squared. So what is a squared? Well, it would be x squared. My second blank is going to be a times b, so it would be 3x. My third blank is going to be b squared, so 3 times 3 would equal 9. So I put 9 there. Now, what I want to do after I have these parentheses filled is I want to make sure I cannot factor it any further. Well, x minus 3, this first set of parentheses, there is nothing more I can do with x minus 3. In the second set of parentheses, I want to see if I can multiply anything to 9 that would add to this 3, right? Well, 3 times 3 will not add to 3, and 1 times 9 will not add to 3, so I cannot factor that any further. This will be my answer, and I am done. Just like in the first problem, this was my answer, so I am done. Okay? On to number 9. I want to look at 3x to the third plus 3 and see if I have perfect cubes. Well, 3 is not a perfect cube. So there's something wrong here. I can't quite do anything yet. So what I'm going to do is look for a GCF. First rule of factoring always. Well, they both have a 3, right? So I can pull out a 3. That would leave me with x cubed plus 1. Now you might be saying to yourself, well, x cubed is a perfect square or cube, but is 1 a perfect cube? Well, what is 1 times 1 times 1? That will equal 1. So the cube root of x to the third is x. The cube root of 1 is 1. I have the sum of two cubes. It really doesn't matter. We use the same process for each one. One smaller set of parentheses, one much larger set of parentheses. It's going to be the same sign, the opposite sign, and always positive. Right? What goes in the first blank? Well, it's a. Let's talk about what our a and b is. Well, our a is just going to be x. Our b would be 1, okay? So a goes in the first blank, b goes in the second blank. The first blank in our second set of parentheses is a squared. So what is x squared? Just x squared. The second blank is a times b, so it would be 1x. The third blank will be b squared, so 1 squared is just 1. Again, I want to see if I can factor that any further. Well, obviously, x plus 1 I cannot factor any further. What about, is there anything that multiplies the 1 that would add to negative 1? 1 times 1 will not add to negative 1. So there's nothing further I can do. So this is, in fact, my answer. All right. On to number 10. I have an a to the fourth. That right now should tell me that, there's no way that I could have the difference of two cubes if there's an a to the fourth. I'm looking at cubes. I'm not looking at quads, right? So I'm going to look for a GCF. Well, there's obviously an a in there. So my GCF is going to have an a involved, right? There's an 8 here. Is 64 perfectly divisible by 8? Yes, it is. So my GCF is going to be 8a. If I pull out an 8a, what's 8a to the fourth divided by 8a? It's just going to be a to the third. What's negative 64a divided by 8a? It'll be negative 8. So now I do have the difference of two cubes because the cube root of a to the third is a. The cube root of 8 is 2. So my a value is going to be a. My b value is going to be 2, right? I want to leave my 8a out front because I did pull out a GCF. I got to keep bringing it with me. I have a smaller set of parentheses and a much larger set of parentheses. Keep the sign, opposite sign, always positive. The sign I'm talking about is this one right here, okay? The first blank in my smaller set of parentheses is just my a value, so in this case it would be a. The second blank is just my b value, so it would be 2. The first blank in my second set of parentheses is a squared. In this case, that would be, my answer would be a squared. The second blank is going to be a times b, so 2a. The third blank is going to be b squared, so 2 squared would be 4. All right. Now what I want to figure out, is there anything more I can do with a minus 2? There's nothing more I can do with a minus 2. Is there anything more I can do with a squared plus 2a plus 4? Let's look at the factors of 4. I have 4 times 1 and 2 times 2. Can 4 and 1 ever add to positive 2? No, it can't. Can 2 and 2 ever add to positive 2? No, it can't. So these will not work. My answer is just 8a times a minus 2 times a squared plus 2a plus 4. All right. 11, 12, and 13, go ahead and give those a shot. Let's see if you can figure out how to work through those. Go ahead, pause the video, give yourself as much time as you need. Come on back when you're done, and let's see how you did. All right, number 11. I'm looking at x to the third minus 64. Well, x to the third is obviously a perfect cube. It would be x. Is 64 a perfect cube? Yeah, it is. The cube root of 64 will be 4. Okay? So in this case, my a value will be x. My b value will be 4. It's the difference, which isn't a big deal. We have a small set of parentheses and a much larger set of parentheses. The first sign is always the same. The second sign is always opposite. The third sign is always positive, right? The first blank in my first set of parentheses will be a, which is x in this case. The second blank in my first set of parentheses is always my b value, which is 4. Okay? The first blank here is always a squared. Well, my a is x, so that will give me x squared. My second blank is always a times b, which would give me 4x. My third blank is always b squared. Well, 4 times 4 would get me 16. Thinking about moving forward, if I could factor this further, there's nothing more I can do with x minus 4. What are the factors of 16? Well, I could have 1 times 16. Will that add to positive 4? No. 2 2 times 8, could that possibly add a positive 4? No, it couldn't. And 4 times 4 will not add to positive 4. So my answer is just that. Okay? On to number 12. I have 4 terms. On the front side, I talked about something that we would do if we have 4 terms. What was that? Well, it's grouping. So I'm going to draw a line right down the middle. I'm going to find the GCF of my first 2 terms. I have 3x to the third and x squared. Well, they both share 2 x's, so my GCF would be x squared. I'm going to go ahead and write that down on the outside. 3x to the third divided by x squared is going to get me 3x. Negative x squared divided by x squared is going to get me negative 1. Okay? Then I have negative 12x plus 4. I want my x to be positive, so I need to make my GCF negative. 12 and 4 are both divisible by 4, so my next GCF will be negative 4. What is negative 12 divided by negative 4? It would be positive 3x. What is 4 divided by negative 4? It would be negative 1. Now I have what I'm always searching for. I have 2 GCFs and I have 2 sets of parentheses that are exactly the same. So I'm going to write the 2 GCFs in a set of parentheses by themselves. I'm going to write the identical parentheses down into one set of parentheses. All right. Now I have x squared minus 4. Again, at the end, you always want to make sure that you cannot factor it any further. Well, I have x squared minus 4. Is x squared a perfect square? Yes, it is. Is 4 a perfect square? Yes, it is. So if I factor that out, it'd be 2 sets of parentheses. I have the difference of 2 squares. So my first blank in each set of parentheses is the x squared, the square root of x squared. The second blank is the square root of 4. Have a positive and a negative. Do not forget about your 3x minus 1. That is our answer. Okay? On to number 13. Right away, I have an x cubed. So I'm thinking of perfect cubes, either the sum of 2 cubes or the difference of two cubes. So I'm going to look at the numbers. Is 4 a perfect cube? It is not. Because 4 is not a perfect cube, I'm instantly going to look for a GCF. Well, the GCF between 4x cubed and 108 is going to be 4. So we're at a 4 out front. What's 4x to the third divided by 4? It would be x to the third. What is 108 divided by 4? It would be positive 27. Well, x to the third is a perfect cube. The cube root of x to the third would be x. 27 is a perfect cube. The cube root of 27 would be 3. So my a is going to equal x. My b is going to equal 3. Right? So now what I need to do is first I'm going to write my GCF out front, make 2 sets of parentheses, one smaller, one much larger. The sign in the first set of parentheses is always the same. Well, that was positive, so we're going to have a positive in the first set of parentheses. The first sign in the second set of parentheses is opposite. The last sign is always positive. Same, opposite, always positive, right? My first blank in my first set of parentheses is going to be my a value, which in this case is x. The second blank in my first set of parentheses is always going to be my b value, which is 3. The first blank in my second set of parentheses will be a squared, so x squared. The second blank is going to be a times b, so 3x. The final blank is going to be b squared, so 3 times 3 is equal to 9. I'm going to check that to see if I can factor it any further. I cannot. So that is my answer. That is the end of our lesson. What we figured out so far today was that if I am trying to factor using synthetic division, it only works if my remainder is going to be 0. If my remainder is 0, then I'm going to use what it told me to divide by, or my binomial, and then I'm going to use the line on the bottom of my synthetic to write a new polynomial. Those will be my factors. If I'm going to factor by grouping, the first hint to that would be that there are 4 terms. If there are 4 terms, I'm going to try to group them. Once I group them, I need to find the GCF of the first group and the GCF of the second group. Those GCFs will go into a parenthesis by themselves. What is left over must be identical. If it's not identical, then the grouping did not work. If it is identical, then I'm going to write those 2 identical sets of parentheses into one set of parentheses, and that will be my factored form. Then finally is the sum and the difference of perfect cubes. Remember that the signs for the sum and difference of perfect cubes will be the same in the first set of parentheses. It'll be opposite for the next sign, and it's always positive for the last sign. Thank you very much for watching the video. Make sure that if you have any questions, you either come see me before school or you bring them into class, and have a great day.